Welcome, my dear student, in our math program for secondary 3. Dear student, today we are taking new lesson in dynamic. It's called, or its title, rectilinear motion. At the first, we take differentiation of vector functions. Rectilinear motion, what you mean of rectilinear motion? If particle moves in a straight line, it moves in a linear motion. Dear student, if a particle moves in a straight line, what you mean? It moves in a linear motion. Position of the particle. What you mean of position of particle? When particle moves in a linear motion, at this moment, it takes up certain position of the straight line. To identify the position of x for moving particle at any time, we choose constant point O on the straight line as an origin point and determine the position direction along the line. Example. Dear student, look at when particle is at position A on a straight line. Particle is at position A on straight line. Then vector x represent 5c vector. C is unit vector on direction OA vector. Note that, dear student, the position of particle is a vector quantity and it can be expressed as function of the time t. Remember, dear student, position of particle is a vector quantity, and it can be expressed as function of the time t. We can represent x vector equal function of t. Displacement. Displacement is known change of its position. Remember, dear student, there is difference between displacement and distance. Displacement means known as change of its position. Displacement, its symbol as a vector equals delta x. What you mean? Delta x, change of its position. X dash vector minus x vector. Delta x is positive when A dash more than A. Velocity. What do you mean of the velocity? Fs equals delta x is displacement of the particle during the time delta t, then average velocity vector, its symbol VA vector, is equal the quotient of displacement over time. We mean VA equals delta x over delta t. Delta x mean x multiply t plus delta t minus xt, change of x over delta t. Then VA equal limit when delta t tends to 0, delta x over delta t. Remember, dear student, we have velocity, average velocity, change of delta x respect to time t equals limit when delta t tends to 0, x multiply bracket contains t plus delta t minus xt over delta t. Therefore, VA equals dx over delta t, or the slope of tangent to the curve of position time. What is the speed? Speed means Vt vector is velocity vector of a body moving in a straight line. Remember, dear student, V t means speed of the particle of the vector of a body. This is velocity vector. V vector t is velocity vector of a body moving in a straight line. Then the speed is standard quantity, expressed the magnitude of the velocity vector. The speed norm v equals norm dx over dt equals norm ds over dt. Then norm of velocity equal norm dx over dt equals norm ds over dt. What is the speed? It's algebraic measure of the velocity vector, and x algebraic measure of position. Dear student, we are translate to example. Stone is projected vertically upwards, and its height x after t second from the projection given by the relation x equals 49t minus 4.9 t squared, where x is in meter. Find maximum height the projection body can reach. Find algebraic of the velocity vector when stone is 78.4 meter high. Then find its velocity. Number C, graph both the position vector time graph, position time graph, and use them to analyze the motion. Solution. Look at the student. Equation xt equal 49t minus 4.9t. This position vector x respect to time t, its equation left hand side xt, right hand side 49t minus 4.9t squared. Since vt equals dx over dt, then by using differentiation respect to time t, vt equals 49 minus 9.8t. Remember, dear student, vt equals dx over dt. We find differentiation. The equation xt equals 49t minus 4.9t squared respect to time t. Then derivative of 49t equals 49, and derivative of 4.9 t squared equals 2 times 4.9 equals negative 9.8 t. The stone reaches the maximum height when v equal 0 or vanished. Therefore, we put the equation 49 minus 4.8 t equals 0. After that, find the value of t. T equals 5 seconds. Maximum height, we find the maximum height at t equal 5. By substitution about t equals 5, then x5 equals 49 times 5 minus 4.9 times 5 power 2. Answer is 122.5 meter. This maximum height which reaches the body. The stone is 78.4 meter high when x equal 78.4. By substitution about 49 t minus 4.9 t squared equals x 78.4 by using factorization. Therefore, 4.9 t squared minus 49t plus 78.4 equals 0 by using division by 4.9 each term. Answer is t squared minus 10t plus 16 equals 0 by using factorization. Then t minus 8 inside bracket times bracket contains t minus 2 equals 0. Find the value of t. T equals 8 or t equals what? 2. Then, dear student, we find v at 2 equals 49 minus 9.8 times 2 equals 29.4 meter per second. This velocity at t equals 2. After that, we find velocity at 8. V8 equals 49 minus 9.8 times 8. Answer is negative 29.4 meter per second. Stone is 79.4 meter once ascending after 2 seconds and once descending after 8 seconds. Remember, dear student, the stone reaches the distance 78.4 meter at 2 moments. The first moment is 2 seconds when ascending. When descending, it reaches at this distance, same distance 78.4, descending after 8 seconds. Thus, the stone reaches at the maximum height 78.4 at when t equals 2 and t equals 8. Algebraic measure of velocity is 29.4 or negative 29.4, the velocity of the stone in 2 cases. We have positive or negative, norm, absolute, positive or negative 29.4. Answer is or must be equals positive 29.4 meter per second. From the position time graph, we find that, look at, dear student, position time graph. T, OX represent time t. OY represent xt. From 0 to 5 and 5, from the interval 5 to 10, the body is reached at t equals 5 as, yes, a 117.6. When the body is moving to, look at, dear student, at t equals 2 and t equals 8, the xt or distance is x student 78.4. When a body is moving ascending after t equals 2, it reaches 78.4. When the body at t equals 8 is decreasing or descending, the distance in this time equals 8 is also 78.4. The stone reaches the maximum height 122.5 at t equals 5. But the stone gets back to projection point once when t equals 10. When the stone gets back to projection point once again when t equals what? Equals 10. Why? Because when t equals 10, xt equals 0. Then the stone gets back to projection point at t equals 10. The ascending stage took 5 seconds. Look at, we have 2 intervals in ascending and descending. From 0 to 5, the stone is ascend. From 5 to 10, the stone is descending. Then ascending stage took 5 seconds and descending stage took another 5 seconds from 5 to 10. The stone was at 78.4 meter height when t equals 2 and t equals 8. from the velocity time graph, we find that, look at the velocity time graph. Velocity time graph represent OX represents time t, OY VT. Look at velocity time graph at t equals 5, yes, VT equals 0. But when t equals 0, maximum velocity is 49. When t equals 10, equals negative 49. Look at the starting initial velocity of the stone was 49 meter per second. When t equal 0, the initial velocity v naught is 49 meter per second. And it gets to decrease during the time interval, open interval 0, 5. Until the stone got instantaneously static when t equals 5. When the stone reaches the maximum height, then the velocity increase in maximum height. In this case, we find area of triangle OAL by using half base times height. Half times 5 times 5 represents time, height OA, but OL represents the velocity 49, multiply by half times 5 times 49, then we find the maximum height is 122.5 meter. Acceleration. What do you mean of the acceleration? Dear student, in this example or in this lesson, we express by distance and displacement. What is the difference between distance and displacement and velocity? After that, we know average velocity. What is the difference between distance and displacement? Displacement means the shortest distance. Shortest distance. We can express it by S vector equal xt vector. It is function of the time t. We can put S equal xt. After that, we know velocity is differentiation of ds by dt. Now we are taking acceleration. What is the acceleration? Is differentiation of the velocity respect to time t. Then we know displacement s equals dx over dt is the velocity, dv over dt is acceleration. Look at the acceleration. Acceleration, it represents A. What is the acceleration? If delta v expresses the change of the velocity vector during time interval delta t, then average acceleration A vector is given by the relation what? Delta v over delta t. What is the delta v change of velocity? What is the delta t change of the time? Then acceleration equals limit when delta t tends to 0, change of velocity v times t plus delta t inside bracket minus vt over delta t. Therefore, acceleration A is differentiation of the velocity respect to time t equals dv over dt, is the rate of change of the velocity vector respect to time t. Or the slope of the tangent of the velocity time graph. Remember, the slope of the tangent of the velocity time graph represents the acceleration A. V, velocity, equals what? Dx over dt. A, acceleration, dv over dt, or d2x over dt2. Remember, dear student, this rule is very important. The velocity v equals dx over dt. What you mean of the velocity? Derivative of position vector or displacement respect to time t. What is the acceleration A? Derivative of velocity respect to 2 time t, or second derivative of position vector x respects to time t. Then v equal dx over dt, and acceleration A equal dv vector over dt, or equals d2x over dt square. Look at the opposite graph, A more than 0. What do you mean acceleration more than 0? We have two cases. The first case, if A more than 0, then V increases. This means that the particle speed up in position direction, but in second case, dv more than 0. But when look at A smaller than 0, when second case, look at second case, v decrease. This means the particle speed down in the positive direction. Look at, dear student, we have two cases of acceleration. Acceleration is positive or more than 0. More than 0 means A is positive. In this case, V is increase, up, motion up, but when acceleration is smaller than 0, then V is decreases. Dear student, in this example, we note that we have two cases of acceleration. The first case, acceleration is positive. When acceleration is positive, what you mean? Velocity or speed is up or increase. But when acceleration is smaller than 0, means velocity is decrease. Look at the opposite graph, represent two cases of acceleration. Opposite graph means acceleration smaller than 0. What you mean? Yes, excellent student. V decreases. This means that the particle speed down in the positive direction. But in the first case, when A more than 0, V is increases. That means particle speed is up in the positive direction. But in this case, look at A smaller than 0. What you mean? V decreases. And particle speed down in the positive direction, or particle speed up in the negative direction. A smaller than 0 means particle speed up in negative direction. Look at when A more than 0, particle speed up in positive direction. But in this case, the particle speed up in negative direction. We have two directions, negative direction, positive direction. Negative direction when speed up, but A smaller than 0. Positive direction when speed up, but in positive direction. Dear student, by the end of this lesson, we means 3 variables. The first, displacement. Second, velocity. Third, acceleration. There is a relation between V with x and A with 2 velocity and position. At the first, what is the relation between velocity and displacement? We know that V equals what? dx over dt over or ds over dt. What is the relation between acceleration and the velocity? Excellent student. The derivative, the first derivative of the velocity is acceleration, but the second derivative of displacement is acceleration. Excellent student. Remember, dear student, we have two types of acceleration. Acceleration more than 0, then v is increased up. But acceleration smaller than 0 when speed is decreased. The first acceleration more than 0, then the velocity is increased. But the second type of acceleration, then a more than 0 means v or velocity is decreased.